Satish Swargman from Cerner.
Hello. I hope you all had a good lunch. I'm glad that it's right after lunch and I'm not between you and lunch. And hopefully this presentation will be like dessert for you. I don't promise, but we'll see. So how many of you think that complying to security controls from the various different regulatory bodies is a pain? Well, almost all, I believe. That's maybe over 70% now. All others seem to be very content with it, looks like. So here what I'm going to talk about is trying to map the security controls from the different regulatory bodies automatically. So I know it's a lot of effort that security analysts, the IT departments, the business owners need to go through to try to comply with the regulations that are out there. I would like to start with a quote from Jody Rell. She's a former governor from Connecticut, and she said, at the end of the day, the goals are simple: safety and security. So security is important. We want to protect patients. We want to make sure that the softwares that we develop do not malfunction, that treat patients safely, like you don't have attackers trying to hack a pacemaker and causing some fatalities or injuries for patients. So with that, now I want to introduce myself. I'm Satish Swargman. I'm a lead software architect with Cerner. I've been with Cerner for over 6 years. I got about 20 years experience in IT. I have a passion for development, security, and AI. I've worked with several of these companies in the past. Worked for a startup company called Humanizing Technologies. We used to do work with AI, concept search. We used to do search for developed applications for patent search as well. Then I worked at pharmaceutical, flight management systems, insurance, the Department of Agriculture, and now I've been working with Cerner. So in this talk, I'll be going over the regulations that are out there, the various agencies that support trying to comply with the security controls that are out there. I'll also be going over one of the AI techniques I used, little theoretical explanation of what latent semantic indexing is that I've used for this, and followed by a demo of how we have automated the mapping of security controls. So in this demo, I'll cover concept search, how we can rank documents that are coming back from the search results, be able to boost your queries, then group the documents that come back together as topics, and try to relate a document to another document based on its similarity, and also try to map the various security controls that are across the different corpuses, like different regulations. Okay. Now, why is complying with security controls important? Here's some data from IBM and Poneman Institute that was published in July of this year. On an average, it costs $150 for a breach data record. In financial, it is $210. But with healthcare, it's the highest. It is $429. And it's only increasing. Like last year, it was $408. So you can only imagine that it's going to increase every year. And you see, it's very important to comply with security in the healthcare industry. Now, if you look at the average total cost of a data breach, again, healthcare is the highest. It's at about $6.45 million, followed by the financial, industrial, pharmaceutical, technical, and so on. So I've just color-coded it based on $1 million range. So if you see, there are the other costs associated with the data breach in the particular sector. Now, here are the various regulations that we probably need to comply with. HIPAA is the most common when you're dealing with EHR. So it's Health Insurance Portability and Accountability Act. It's widely used. Sometimes these controls are very abstract. They're not very specific or granular enough to kind of follow and implement them. So you need to seek help from other security controls or the things that are published out there too. NIST is a very broad set of controls that are available. One of the things I follow closely is the NIST 800-53. There have been several revisions of it, and I think last year they just published one, which is a Rev 4, which seemed to be very granular and a pretty good standard to follow. Then there is also the Center for Medicare and Medicaid Services. They are pretty stringent set of controls that need to be applied, especially if you're dealing with the state of Montana, for example. They require you to follow CMS. And if you're dealing with credit card data, there is the PCI data security standards that you need to be complied with. There was Safe Harbor in Europe that we used to follow. Now it is GDPR. One thing that comes to mind with GDPR is about access and privacy. So they did add a provision saying that a person should be able to opt to purge the data, historical data. So this interesting privacy concerns that were brought up, and they're trying to have that as part of the any applications being served or hosted in Europe. There are also various ISO standards that are available. The one that comes to my mind is 27001, which is related to information security management. So several other areas have other standards that can be followed as part of the ISO. And there is Department of Defense, where you have the security technical implementation guidelines. They are very granular. I think there are security controls based on where and how you deploy it. For example, if you're deploying it to a Linux operating system, you may have to adhere to Red Hat Linux controls. And even if you're deploying to Windows, there are other controls for Windows operating systems. And there's also some controls available for application security development. And I've worked very closely with the application security development guidelines from the DoD or DISA. Now, there's so many other agencies that try to support building secure software and deploying it securely in the various environments that you would like to host. One popular one is the OWASP, or it is Open Web Application Security Project. They have several small community projects over there. They do have some open source vulnerability scanning software that is there that can scan and identify vulnerabilities in applications that's being deployed. There is also another one that I've closely followed, which is the application security verification statements. And these apply to securing web applications. Few other things, like the Web Application Security Consortium is also there. It defines certain threat classifications. It is an open source one developed by a set of industry experts, and it is built in a way that you follow the secure best practices for web applications. Then you have CIS. There are about 20 domains in it. There is also SANS, which provides training and education for security, and they do have some controls which map to vulnerabilities identified by certain vulnerability scanning tools. So I was just trying to give a brief overview of the different regulations and the communities that are out there to build software securely. Now, from the regulations, what companies usually do is they build their own policies. It may be a policy for information classification. Maybe you want to classify your data as either classified, restricted, internal, confidential, or open to public. And based on those, you may come up with some step-by-step instructions and create procedures for that. Then as you create these, the standards being evolved and how you would like to implement those step-by-step instructions. If you were to deploy your application to the cloud, based on whether it's a private or public cloud, AWS, Google, or even Azure, you may be needing to follow different guidelines for that. And then you have the security controls you can apply. Like, for example, maybe you want to apply a web application firewall to prevent malicious attacks from trying to attack or exploit your application. So now, when a security analyst looks at it, he's overwhelmed. You've got to comply with HIPAA, maybe. If you're dealing with credit card data, PCI DSS. If you're going to deploy to some state which has to follow certain regulations, maybe CMS applies. So there's so many things you need to map to. And if you're trying to give all these to a developer or give it to a business owner, they may be confused because they may have already gone through this several times. And maybe some of the things that they've implemented to secure applications are already out there. So how do you map and reduce that problem for them? So if you look at the secure software development lifecycle, here are the different phases. You got the requirements, where you try to come up with security requirements, which mostly are non-functional. So I would say anytime you're dealing with the 3 pillars of security, which affects like confidentiality, integrity, and availability, then you have a security requirement. Then in the design phase, you look at the secure design reviews. You got threat modeling. It's a structured approach to identify and quantify risks associated to an application. In the development phase, you could scan the source code and try to identify vulnerabilities. And you can also find vulnerabilities through code reviews or peer reviews. And in the test environment, you have the security test cases or exploratory tests you can run to see if there are certain security issues in the application. Like if you're trying to deploy an application for multi-tenancy, you want to make sure that a person is not authorized to see another tenant's data that they're not authorized to see. So things like that, you may want to do some functional tests. And you also have some dynamic analysis tools that can scan your deployed application and see, submit malicious payloads and see if your application can be exploited. And finally, when you're trying to deploy it to production, you probably would go through a set of checklists. You can have application security monitoring, like IDS, which is intrusion detection systems, and intrusion protection systems. So there's so many things out there. And how to make sure that you have mapped and complied with those security controls from the regulatory bodies that are out there. So in this talk, I'm going to focus more about mapping the security controls. Just to, again, give a brief overview of security and secure software development lifecycle. So to solve this problem, try to use an AI technique. It is latent semantic indexing. It means latent means hidden. Semantic means it has a meaning. And indexing is about searching and retrieving. So here, the latent semantic indexing is based on the core principles that similar documents have similar word frequencies. It was initially developed by Telcordia in probably the 90s, and it improves the ability to search documents. This is different from keyword search. Like, for example, in this case, if you're trying to search for the word American president, you're probably looking for articles related to Donald Trump. The articles may not contain the fact that he's American president, right? So when I'm searching for that, you want to be able to get back conceptually related documents, even though the term doesn't exist in the document. So that is about keyword search, about concept search. And here, concepts replace keywords to improve your search. To further explain it, say I'm interested in physics. I'm searching for the word light waves. There could be these 3 documents out there. First document talks about particle and wave models of light. There's another document talking about surfing on the waves under starlights. And then the third one about electromagnetic models for photons. So if you look at this, the first and third document are relevant to my search, because I'm interested in physics and not in a physical activity. So you see, when you're trying to search, you want to get conceptually related documents back. Now, if you were to do a lexical matching or keyword search, you would get results from the results that come back would be related to the first and the second document, as you see, because they contain the exact word over there. Now, just want to explain the metrics behind it. Just like Zach, I'm hoping that you all figured it out and how to compute the singular value decomposition that is related to latent semantic indexing. So now if you look at this, what happens with LSI is you're trying to decompose the original matrix. The original matrix comprises of words on documents mapped together. So in this case, you're trying to decompose it to a singular value decomposition, which is a reduced dimensionality. So here, the original word document matrix is represented by word to topic, topic to topic, and topic to document relation. So here we have introduced the concept of topics, otherwise called as concepts. And that was about singular value decomposition. To further explain the math behind it, it involves certain eigenvectors and eigenvalues. Hopefully, if you figure this map out, you'll be like Neo, cracking the matrix and defeating Agent Smith. So for those who are interested, you can see the 3 different matrices can be calculated. You can use MATLAB. There are so many other software libraries out there, open source libraries that can be used to compute SVDs given a Word document matrix. Now, further trying to look into it, this is how you map the query to the reduced case space. So once you've computed the other remaining matrices, you can pass your query parameters to it, as seen over there. You would be able to compute the Q prime, and based on that, you can actually retrieve documents and words within a proximity. That is, you look at the cosine similarity and the best match. When you get the results back, you do have some score associated with it. So based on the score, you can actually sort it and rank your documents that come back. So it seems to check out, isn't it? The math, hopefully. So to further explain this, say I've just brought up an example of the light waves. They may be distributed in this format, like you have all of the words in there that are mapped to the topics. That is, the U is being calculated based on the associations, the singular value decomposition. And if I'm trying to search for light wave, the way I would pass in the parameter is substitute the occurrences of it by 1. And if it doesn't match, then you would substitute it by 0 in the corresponding value in the matrix for Q. So I've also noticed I have noticed by trial and error that I could apply a boost to it, that if I wanted to increase the relevance of a document, say I'm more interested in light than wave, I can boost it by giving a value of 2 and 1 for wave, and that actually changes the search results that come back significantly. Yes?
What is S-inverse again?
S-inverse is computed. It's a singular value decomposition or a set of single. Yes. They're already computed from the previous step. And then you're taking S-inverse to compute the queries for that. I'm glad someone is interested in math now. Thank you. So now if you look at this, you get the value Q prime from that. And based on it, you look at the cosine similarity. So once you get Q prime, you're trying to map it to the documents out there, see how closely or similar the query is to the document. So if you look at this, now you get these values back. So the first document is the highest ranked one at 0.96. The 5th document is second highest at 0.91. And you also have you have a score, you have ranking, how close they are related to each other. And that's how you would search for results and get the values back. So now, It's so hard to imagine, right? These are all multidimensional. I couldn't visualize. I wanted to give an example of a 3D matrix or anything, something like that. But in fact, there's a multidimensional cluster. All these concepts, depending on how you view it, are all like scattered across. For example, you may have some documents related to football or boxing. And then you may have other things related to politics. They're all grouped differently. Like you can actually group them under different topics based on how they're related to each other. But the idea behind this LSI is about reducing the dimensions or dealing with fewer topics. So things like football and boxing may be grouped together as sports. I'm just trying to illustrate how it would be. Or you're trying to group it to fewer topics than you would try to group it with the entire document corpus. So theoretically, you may have, if you have a Word document matrix, you may have as many topics as there are words. But now we are trying to reduce those dimensions with this. So here is a simple computation. Say you were to deal with 1 million words in 10,000 documents. Then you're going to have 10 billion records. So with this reduced dimension, if you're limiting your topics to, say, 200, now the values you need to store is 200 million at the max. That is about 1/50th the size of the original matrix. So it's optimizing your search as well. So now these are the strengths of this technique or this methodology. It's for information retrieval. I just described how you can query and get conceptually related documents. You can use it for information filtering. Say, for example, that you're interested in a certain topic, like sports. You can actually filter that. Now, since they're all grouped together and the topics of your interest, you can further filter that information. Sometimes I know what is relevant to me may not be relevant to you. So that's why by going by the topics, you can actually further filter it and go and search for documents that are of interest to you. You also have relevance feedback. Like as I said, there's a score coming back. So it's providing automatic relevance feedback for you as well. And there's also cross-language retrieval because it's looking at words and it doesn't matter which language you're dealing with. It just retrieves information. It tries to groups things together. So if you're writing something in Korean or anything else, it could actually group those things related to that particular language. So now, here are the problems with keyword searching. The problems with synonymy and polysemy. So as an example is, sometimes if you're talking to a girlfriend, you tell her, you're beautiful. Maybe she won't understand your accent, you may take it differently, so you have to go about explaining to her, no, you're attractive, you're stunning, and other things, right? So these are all conceptually related words. And these are the problems with keyword search, that it won't return documents if it does not contain the exact word that you're looking for. Concept search should solve that. So in return, maybe you would expect that you're being called funny, but that could be skeptical, who knows? So unless you explain further that you're humorous, comical, you get the point, you get the concept, and so thereby you can be happy, and the other related words for that would be content and joyful. So if I'm searching for happy, maybe the document that comes back has a word called joyful or upbeat. Then there are also problems with the polysemy with the keyword searches. Like the same word could mean different things. In this case, a mouse can be a computer mouse, or it can even be a rodent. Well, unless the document has that a mouse is playing with a mouse, computer mouse, I don't think you want to know about that document that comes back. So due to these problems, there's noise, there's decreased recall, and poor precision with keyword searches. So it does return contently unrelated documents. So now with that, I would like to go through a quick demo of how we have done it. I didn't want to show the math too much, but I felt that by showing the demo, you will be able to see how we can search for conceptually related documents and how we apply it in the apply it for security controls that you would like to map together. So initially, what we did was I looked at documents that are related, that are there in a TRC or a text retrieval engine. They have certain uh, uh, articles from hospitals that have de-identified and stored. Like there's some information about conditions, treatments, and so on that are out there. So I was trying to go and see how effective this algorithm is for that. So if you were to search for this, let me see. So I'm searching for some articles related to TRC within that. So as an example, all I did, I didn't even search for anything. I just looked at the document corpus. I think you're not seeing it. Yeah, sorry. Okay, so here, I've just looked at the document corpus. So if you see, there are some articles that come back with something that talks about, you know, the quantitization, what's it, quantification, I think there's a spelling mistake there in that, and characterization for clinical scanners. So what it did is I just took the unstructured text that was out there and tried to apply LSI on it. So with this, if you see, I was trying to parse this. I was trying to stem the words. So in this case, stemming would mean that you're only looking for the root words. Trying to see like surgical, for example. Now, there could be different words associated, multiple different things, but I just used the root word for it, or used a technique called Porter stemming for it. And now I want to demonstrate some certain other characteristics. Say, for example, I'm looking for cataract treatment. So when I search for it, I can get results that are related to some findings, some cataract. They talk about nuclear cataracts over here. So if I'm looking at the word map, they actually, you can see certain information about cataract, lens, and so on. And you would also get results back with other treatments for it. So what I observed is when I was trying to search, it did retrieve some information that didn't have the word cataract. It did come back with results saying like for laser treatment and other things for eyes, for surgery on eyes, or not specifically talking about cataract. So if you see this, so just use this as an example. I felt it was pretty effective. So what I later did was try to go and map it to the security controls that are out there. So you got NIST, you got the application security verification statements, and so on. So in this case, looking for the NIST mapping, I get documents related to NIST. Oh, but of course, I'm searching on cataract within the security controls. That doesn't exist. So when I'm searching here, you have all these like coming back, grouped together. And say, for example, I'm looking for authentication controls. Just looking for authentication. And in this case, I get all the controls related to authentication. So they talk about revoking authenticators and so on. It's a small set of controls. Sorry. Okay. So it just talks about identification and authentication and implementing certain administrative procedures. There are other articles that come back too, like when I'm few things again related to identification and authentication. So you have over here, the information system should dynamically provision identifiers. So these are the controls that come back from NIST. Now what I'm trying to do is map it with another document corpus. Like there's NIST and there's also ASVS controls that are out there. So in this case, when I'm clicking on mapping it, I get this like for the ASVS requirement, and it's an authentication requirement. It says that verify that the password change functionality requires the system's current and new passwords. But I can go and try to find conceptually related documents to that in a different document corpus or within the NIST space for it. So using LSI, you can submit the queries, and then now I have this article which talks about the verify that password change functionality requires users current and new password. Now I can go and look for a related NIST mapping for it. So this, actually there are several different things it talks about. So it has some information about password-based authentication and so on. So one of the problems I faced was before, or like when we submitted this for this talk, I had an older version of NIST. But now since then, I got more finer, granular controls over there. So things keep evolving. The new threats identified, and you have new revisions coming from all the regulatory bodies too. So it is important that we have some sort of automated mapping for these. It's not easy for a person to go and map it frequently. This is to aid all the security analysts to map the documents that come from all these different agencies. So if, as you see, as we get these security controls, you can try to map it and see all the controls that you have complied with. So that's one example that we're using for it. And then you can also search, provide another example over here. I was talking about boosting it. So say, for example, I'm searching for authentication and authorization. So in this case, I should get back results related to authentication and authorization. But right now, I didn't apply any boost. So it says more about authorization, but not about authorization in this document corpus. So if I were more interested in authentication, for example, I can actually give it a boost. As you've seen it in the query parameter, how you can substitute those values. When you do that, it will then give more information related to authentication security controls in that manner. So there are several ways a person can go and try to search for security controls that are relevant to the ones that they need to be complying with. And if you see, there's another one that I wanted to specify is all these are grouped under topics. So we have used stemming. So I haven't used the actual words in there. There's another technique that can be applied like lemmatization, where you're having a word dictionary. A dictionary of words, you can lemmatize it, but in this particular case, I prefer to use a Potter stemming, which is actually using the root words for them. And now with this is very similar to topic modeling as well. So you have all these documents grouped under these different topics over here. So if you're interested, if say, for example, a person is interested only in authentication, identification, and so on, they can just filter it further. And I did use certain stop words, like the document, it was unstructured data that came back. So stop words would be, for example, if the column was a title or condition, you don't really want to be indexing based on those words. So we used stop words and stemming prior to applying it with LSI. Yes, a couple more minutes. I'm almost done. Yeah. So now I'll go back. Oops. The other one. Just. Okay. So now we've just seen the demo. Next. Oh. 1 second. I don't know what happened to my mouse pointer. I'm like trying to look at it. Okay. All right. So we just looked at the demo now. And then what I want to quickly go over is there are some alternate methods that can be applied. There is the latent Dirichlet allocation, which is very similar to LSI, but it's based on Bayesian probability. It's probabilistic based. There's also a hierarchical Dirichlet process, which is based on unparameterized topic modeling. So you don't need, and it's about reducing the topics without passing any parameters. There are also other deep learning methods like word to vector, doc to vector. They all are based on the fact that they're trying to group similar words together along with the topics. And this, I think, word to doc, word to vec, and doc to vec was developed by Google. Now, here are some of the open source softwares that are available. You got Python is becoming very popular now because of AI, I believe. It's actually gone over Java at this time. There is GenSim, scikit-learn, PyLDavis from Python that can be applied. There are several other things out there too. There is Java, where you have the Java matrix package from NIST. You got LinkPipe for topic classification and sentence detection. I've used sentence detection. I've applied the very similar concept like I've applied for the document corpus across for to extract sentences from within a document. So I've treated sentences to be different, like just like how we consider documents in a corpus. I've treated sentences within a document similarly, and tried to extract the most relevant sentence out of it to provide an abstract. So, and you see how these are the ways you can map security controls. And taking these, we would try to generate tasks for the development teams and see if how they can comply with security controls. Do you have any questions? Done. All right. Good. Thank you.